squared plus 2x times 3 is 6x. Draw my line. 10x squared minus 10x squared is 0. 11x minus 6 is 5x. And then I just carry my next part down. Got a plus 3 there. Now the next thing I do is see how many times will 5x go into 5x. The answer is it'll go in one time because it's the same thing. 1 times 5x gives me 5x. 1 times 3 gives me 3. So I draw a line and subtract them. Again, I get 0. So the answer to this problem is 2x plus 1. Okay, so making progress. Making progress here. Okay, next thing we want to do something a little bit different. What if I have, let's throw a minus sign in here. What if I have 2x minus y divided into 6x squared plus x times y minus 2y squared. Now notice we have variables in x and y. It's not really going to change much at all about how we actually do the problem. We're just going to have to be a little bit more careful to make sure we deal with the x and the y properly. So the first thing we do is see how many times can 2x go into 6x squared. Well, 2 goes into 6 3 times, so I'll write a 3. X goes into x squared x times, so I'll write an x there. And you can check that. 3x times 2x. 2 times 3 is 6. X times x is x squared, so that's correct. So let's multiply this times this. 3x times 2x, we just said was 6x squared. 3x times negative y is negative, so I've got to put the negative sign there. 3 times x times y. Now draw my line. Now, I'm subtracting this minus this. 6x squared minus x, 6x squared is 0. xy minus a negative 3xy. Anytime you have, if you recall, you're subtracting a negative number like this, like 3 minus negative 4, well, you can kind of put a plus here and a plus here because the negatives sort of cancel out, and you end up adding them together. So that's exactly what we're going to do here. xy minus negative 3xy is basically the same thing as xy plus 3xy. So I'm going to have 4xy, positive 4xy, and I carry down the next term minus 2y squared. Okay, and then the next thing I do is see how many times can 2x go into 4xy. 2 goes into 4 2 times, and x goes into xy y times. Now that may seem strange, but again, you're just picking something to make it work out. To check this, 2y times 2x. 2 times 2 is 4, that part's correct. X times y is xy. So that's all I'm doing. I'm just filling in letters and numbers to make it so that when I multiply them, I end up with what I wanted. So 2y times 2x is 4xy. 2y times negative y is negative 2y squared. Draw my line, subtract them, and I'm basically at the same thing on the top and the same thing on the bottom, so I have a 0 here, no remainder. So the answer to this problem is 3x plus 2y. And again, if you were to take this and multiply it by this and do the FOIL, first, outside, inside, last, you will end up with what's in the middle here. So you can see that even in the case that we have problems that look a little bit more complicated because we have different kinds of variables in there, they really aren't all that different. We're pretty much doing the same thing in all these cases. We're just, you know, the problems are a little bit harder sometimes. So let's say I had something that looked kind of like 3x minus 2y divided into 3x squared plus 13x times y minus 10y squared, like that. Again, 3x goes into 3x squared, 3 goes into 3, 1, and x goes into x squared, x. So I put an x up there. Multiply this times this. X times 3x is 3x squared. X times negative 2y is negative 2x times y. Draw my line. 3x squared minus 3x squared is 0, so I'm going to drop it out. 13xy minus a negative 2xy gives me a positive 15xy because I'm subtracting a negative number. If you forget the reason why when you subtract a negative number you end up adding it, just go back to the section on adding and subtracting numbers, and there's lots of examples of that in there. Next thing I do is I drop down my final term, 10y squared, and then I see how many times can 3x go into here. How many times can 3x go into 15xy? Well, 3 goes into 15. How many times? 5 times. Okay. And x goes into xy, y times. Because 5y times 3x, 3 times 5 is 15, x times y is xy. So that's going to be 15xy here. And 5y times negative 2y is negative. 2 times 5 is 10. Y times y is y squared. Draw my line, and I've got the same thing on the top and the bottom. I'm subtracting them, so I get a 0 here. The answer is x plus 5y. And that is the answer. Okay? So work a few more here. You can see we're getting a little bit more complicated with each round, and I tried to pick some problems that do that. They started out with numbers, basic numbers, something sort of familiar, and then I start out with fairly simple polynomials, and now we've got polynomials with 2 variables and with negative numbers thrown in for good measure, right? So things get a little bit more complicated as we go. Okay. The next one I want to do is one that looks like this. What if I have 3x plus 2 divided into 6x cubed plus 10x squared plus 7x plus 2. Now notice this is a third degree polynomial, so we've got a longer polynomial here. But it's the same thing. 3x goes into 6x squared. Well, it goes 2x squared times, because 2x squared times 3x, 2 times 3 is 6, x squared times x gives me x cubed, so I'm going to go ahead and do this multiplication. It's going to give me 6x cubed, and then 2x squared times 2 gives me, 2 times 2 is 4, x squared comes along for the ride, and then I draw a line. Then I subtract. 6x cubed minus 6x cubed gives me 0. 10x squared minus 4x squared simply gives me 6, and x squared comes along for the ride. And then I just carry down my next term, 7x. Now I'll do the same thing I did before. How many times does 3x go into 6x squared? Well, it goes 2x times. Why? Because 2x times 3x, 2 times 3 is 6, x times x is x squared. So let me go and do that multiplication. That's going to give me 6x squared, and then 2x times 2 gives me 4x. Then I draw a line again. 6x squared minus 6x squared gives me 0, so I'm not going to write that down. 7x minus 4x gives me 3x. And then I've got to carry down my last term, which is a 2. Now, I just got to see how many times can 3x go into 3x. Well, it's going to go 1 time. And then I'm going to multiply 1 times 3x. It's going to give me 3x. 1 times 2 is going to give me 2. Subtract these two. 3x minus 3x is 0. 2 minus 2 is 0. So I get a big fat 0 there. So this divided into this is this big polynomial up here. And I promise you, if you were to take this and multiply it by this, you would get what's in the middle. So it really doesn't get all that terribly, more complicated if you have additional terms in there. It really doesn't get that bad at all. You just got to keep your terms straight and make sure you understand, keep all your subtraction and make sure and keep all your signs straight. Now the tricky thing with these problems is that if you forget to do your signs or something like that in the middle of one of these subtractions, you're going to have a hard time finding it because it'll take you some time to figure out the exactly where your error is. Okay, I'm going to do two more problems, and these are going to be a little bit more complicated because they're going to have a remainder at the end. Let's see how this happens. What if you had 2x plus 3 divided into 2x squared plus 5x plus 2. First thing I do, 2x goes into 2x squared. Well, it only goes x times. Why? Because 2 times 1 is 2, and x times x is x squared. So let's do that multiplication. I've got 2x squared, and then 3 times x is 3x. Okay? And then I subtract 2x squared minus 2x squared gives me 0. 5x minus 3x gives me 2x. And then I simply carry down my last term just like before. Nothing's really different. Now I see how many times can 2x go into 2x. Well, it can go 1 time. Now let's do this multiplication. 1 times 2x gives me 2x. 1 times 3 gives me 3. 2x minus 2x gives me 0, so I'm not going to write it down. And 2 minus 3 gives me negative 1. Now this is different. So far, when we've done all these, we've subtracted, and the end we always got a 0, so there was no remainder. Now there's a remainder because I've got a number left over here, negative 1 in this case. I've got no more terms to drag down to help me out, and 2x plus 3 definitely does not go into negative 1 an even number of times. So the way you write this in algebra, the answer to this problem is x plus 1, and then what you do at the end, you add the remainder, which is negative 1, divided by what you divided by here, 2x plus 3. And if you remember, draw a little squiggly line through here. If you remember, that's exactly what we did with the numbers. The answer was the number up on the top plus the remainder divided by the divisor there, and that is the answer to the problem. All it means really algebraically is that you can divide this into this many times, but even when you do that, you have something left over, and so you have to account for that. It's called a remainder. Okay? So it's not really too bad. You're doing the same process. It's not like you're really changing the problem. It's just at the end, when you do all your subtraction, you don't end up with 0. You end up with something else. Okay. Moving along, one more problem. And this one should have a remainder too. Let's see. X minus 2 goes into 2x cubed plus 4x squared minus 2x plus 3. Okay? So let's start off by saying x goes into 2x cubed. It's going to go 2x squared times. Why? Because 2 times 1 gives me 2, and x squared times x gives me x cubed. So performing that multiplication, I'm going to have 2x cubed out here. And then 2x squared times negative 2 is negative 4x squared. Okay? So I draw my line. Now be careful here. 2x cubed minus 2x cubed gives me 0, so I'm not going to write it down. 4x squared minus a negative 4x squared. When you subtract the negative, it's like adding the number. So what I'm actually going to get here is 8x squared. Okay.